If you're looking to learn SQL, then you have come to the right place. This two-part series is going to start with learning to write SQL queries ranging from fetching data to sorting, ordering, filtering data to performing joins and aggregations on data. And in the second part, we are going to do some practice exercises using the concepts that we're going to learn today. So let's get started. SQL stands for Structured Query Language. It is the programming language used to access data residing in databases like SQL Server, Oracle. The data mostly resides in the form of tables, which means it has rows and columns. SQL queries can be written to fetch this data, to read this data, or even to manipulate this data. So let's get started with our basic SQL queries. We start with fetching the data from a table called employees. To fetch any data, we start writing a select query. So you do a select, and if you want to fetch all the data, we do a star. We simply say from and the table name. So the table name is going to be employees. When I execute this query, I see the output, the complete output. The first row that you see over here, the headers are the column names: employee ID, full name, department ID, salary, hire date, and manager ID. And all the remaining rows that you see are the actual data records in this table. Now, if I want to select only particular columns, I can also say, or I can also select specific column names. So if I just want to select employee ID and full name, I can write those column names and run my select query. So if I just execute this query, I get only these two columns which I have mentioned in my SQL query. You can also sort the output in ascending or descending manner based on the values in any particular column. So let's say now we want to sort the values or sort the output by the values in the full name column. So we can simply add an order by clause. So order by, and mention that column based on which we want to sort the output. So if I want to sort the output by my full name, I just will mention the full name over here, and by default the output will be sorted in ascending manner. So we can see over here that A has come at the top, so this will be sorted alphabetically in ascending order. Now let's say I do not want the output to be sorted in an ascending manner, but I want the output to be sorted in a descending manner. So we can just use the keyword descending, or just DESC, add it to our order by clause and execute our query, and now the sorting will be performed in the reverse order. We can also select the top n rows. So if we want to select only the top 2 rows ordered by or sorted by the full name in ascending order, we can simply say select top 2 star from employees, and we can use our order by clause. So order by full name. Since we have used a star over here, we are going to get all the columns in the output, but only 2 records. We can also filter the data based on values in particular columns. So if I now want to select only those employees for whom the department ID is 1, I can add a where clause and mention the value that I want to filter on. So where department ID is equal to 1. And if I execute this query, I'm going to get only those records for which the department ID is 1. In certain cases, maybe I want to have multiple conditions. So now I want only those employees whose department ID is 1 and whose salary is greater than 50,000. So I can add another clause using the AND keyword and then specify my second condition, which is going to be salary greater than. Use the mathematical operators for greater than, less than. You can also have greater than, equal to, and say 50,000. And now the output result set will be filtered based on both of these filter criteria. We can also use OR to filter the data. So let's say We now want to select all the employees whose department ID is 1 or those employees whose salary is greater than 50,000. So instead of using this and over here, let's just copy it over here. We will replace this and by or. And now we are going to get all the employees whose department ID is 1, or if the department ID is not 1, their salary should be greater than 50,000. We can also filter on a range of values. So if we want the salary to be between 50,000 and 100,000, we can use the between keyword. So now you can see that only those employees have been selected whose department ID is 1 or whose salary ranges between 50,000 and 100,000. Now this between can obviously also be written as a combination of greater than equal to and less than equal to. So you can say salary is greater than equal to 50,000 and so now you have to mention your column name again. Salary is less than equal to 100,000 and you will have to put this in a bracket so that this whole expression is evaluated as a single expression and then the other expression is added to it. So if you execute this, you will basically get the same result. You can also check on null values. So if we want to select only those employees whose manager ID is null, we again have to add this condition. So any condition for filtering the data have to be added to the where clause. So we can add this, mention the column name on which we want to specify the condition where manager ID is null. And if you execute this, you're going to get only those records where the manager ID is null. Similar to this, you can also filter for not null. So if you're filtering on not null, you have to say is not null. So you cannot write manager ID is equal to null or is not equal to null. You have to use these commands is null and is not null. So if we do this, we're going to get all the records for which the manager ID is not null. Another filtering that we can do is we can check whether the name starts with an A. So we can check using wildcards. For this example, we are going to say where, and then we can say where full name, like, and use our wildcard. So if we want the name to start only with, let's say, only with an A, we will say A and %. So there can be any number of characters after that, which can have any value. So you have to use a like with a %, and you will get only the single record that we have. If you want all the employees where A is an alphabet that exists anywhere in the name, you can have a % character at the beginning, which means there can be any number of characters before the A and any number of characters after the A with any value. And if you execute this, you will see that all those records which have an A in them, so here is an A in Brad, there is an A in Julia, there is an A in David, in Alan, there are 2 A's and so on. In Clark, there is an A. So all those records which have an A anywhere in their name have been returned in the output. Now, what if we want to filter on multiple values in the same column? So now I want to select all the employees whose department ID can be 1 or whose department ID can be 2. So you can also write it this way using the or word. Department ID is equal to 1 or department ID is equal to 2. And if you execute this query, you're going to get only those employees whose department ID is either 1 or 2. But if there are multiple values that you need to check on, then an easier way to write this query is using the in keyword. So with in, you can specify a list of values. So you just mention an in over here, and within brackets, you put your values. So 1, 2. And the query is much easier to write, as you can see over here. Now always keep in mind that if it is going to be an alphabetic value or alphanumeric value, that means a string value, you have to enclose that thing, your value, within quotes. Since these are integer values that we are dealing with, that's why we are just putting the value as is. Now there's also an option to select unique records based on some column value. So if we look at the data over here, we can see that the department ID are repeating for multiple employees. What if the requirement is that we only want to know that which all department IDs exist in the employee table? Then we can perform a distinct on the department ID. So we can say select distinct and the column name that you want to select distinct values on from employees. So if you just run this query, you're going to get distinct values of department ID. You can also select a distinct on multiple columns. So let's say now we want all the distinct records, all the unique records for which the value of department ID and manager ID, the combination of these values is unique. So I can just add this particular column over here. And now I get all these records. So this particular combination has to be unique. You can also perform a count on the data in the records. So if you want to know the total number of records in your table, you just say select count star from employees. And you will get the total number of columns in the output. Now you can see that at the top you see that it says no column name. Why it says a no column name is because this particular value, this is not a column that exists in the table. This is a calculated column. So you can provide an alias over here. You can say as count from employees and run this query, and whatever is the alias, the column alias that you have provided over here will become your column header. So it is more easy to use in more complex queries. Now when we run this query, select count star from employees, it counts all the records in the employees table and gives us the total count. But what if we wanted to find out the count for each department? So how many employees are present in each department? So we want a count of the employees in each department. In that case, we have to use another keyword which is called group by. Group by is going to categorize our data based on whichever column we have selected. So in our case, we wanted to find out the count by department ID. So let me just copy this query over here. So in this case, what I'm going to do is I'm going to add a group by clause, and I'm going to specify that column based on which I want the count. So I want the count for each department. So I'm just going to say group by department ID. So if I execute this query, I get these values. Now I do not know for which department I've got which count. So what we have to do is we have to add that particular column which we have grouped by here in a select clause and execute this query. Now you have to remember, whenever you're using the group by clause, you cannot add any columns which are not present in your group by. So if you say group by department ID and you add employee ID as well, you're going to get an error message when you try to execute this. Why is this happening? Because it cannot pick the employee ID if you group all the records in department ID. So what you're saying basically is that I want the count of employees in department ID. In the output, I will be getting only one record for each department ID. Now I have three distinct values of employee ID, and which value should I output for that one distinct record of department ID? If it is sounding confusing, then try executing and try putting it down on a paper and try to see what you're trying to achieve over here, and you will understand what is the confusion over here. So the confusion is that for a single record, it has got 3 different values for employee ID. So if you want the employee ID value, you have to perform some aggregate function on it. So you have to choose. So which employee ID value I want to see in my output? Maybe you want to see the maximum employee ID value. So you have to say maximum employee ID. When you do a maximum employee ID, it is going to limit those 3 values. It is going to pick up the maximum value out of these 3 values, and therefore it will be a single value. All this will be calculated based on the grouping by on department ID. So the maximum employee ID value for that department ID is the one that you will get over here. Again, there is no column name because we did not give it as an alias. So our alias actually went here, which is wrong. So let's put it back to the right place. And we will give another column alias called max employee ID. And now execute this query. And now you will get this result. Now another requirement might be that now I know the departments and the count of employees in all those departments. I want to select only those departments whose employees or the count of employees in which department is greater than 3. So I do not want department 2 and department 3 in my output because the count of employees is only 3. I only want to see those departments whose count of employees is greater than 3. In that case, what we can do, what we are saying is we are basically asking to filter the output result set again. So a filter condition. Now, if you remember when we needed to filter the data from the table directly, we used the where keyword. Now, in this case, we cannot use a where keyword because we are going to have a filter condition on the group data. So when you want to apply a filter condition on the group data, you have to use having. So having count star greater than 3. This is essentially like the where condition that we used on the table. But when you want to add a filter to the group by data, then you have to use the having keyword. So if you execute this statement over here, you're going to get only that one single record in the output. You can also perform a count based on the value in a column. So you can also say select count. And if you want to count only the distinct department ID values, you can say distinct department ID from employees. So what this query is going to do, it is first going to calculate how many distinct department IDs are there. It is going to identify those distinct department IDs and then perform a count on them. So you will get only the values which are 3. So there are 3 distinct department IDs in your data. Now let's say that we have the department ID, but we want the department name. Now where is this department name? It does not exist in our employees table. So we can see that there's a department ID, but there's no department name. So I really cannot make out anything if we tell it to the business user that for this department, we have these many employees. Just by identifying the department ID, he will not be able to understand what we're talking about. So we need some more description for the department ID, like the department name. Now this department ID description exists in another table called the department table. So select star from department. And now we can see that we have got some departments with the department name. So department ID 1 actually means HR department, department ID 2 means sales, and so on. So how do I bring the department name as well in my final result? So to do that, I need to combine the data from my employees table and the department table. Combining the data in SQL from 2 different tables based on some key column like the department ID over here. So I'm going to match on the department ID and pick up the department name. So this combining based on matching column values can be achieved by something called joins. So basically I'm going to perform a join between the employees table and the department table. So I'm going to say select employee ID and department name. Now, employee ID is in the employees table and department name is in the department table. So I have to mention both of these tables here. So I'm going to say from employees, and then I need to join on the department table. So department table, when you perform a join, you need to identify the column based on which you want to match the data. So you have to say on. So this is the column based on which I'm going to match the data. Department ID is equal to department ID because that is the common column in both the tables. Now I'm going to try to execute this query and I'm going to get an error message saying that the department ID column is ambiguous. So because the same column name exists in two tables, SQL is not able to identify from which table we are referencing to when we mention department ID over here. To solve this problem, again, we have to give aliases to our table. So table aliases, you can give the name EMP and department can be DEP, and we can do employee dot. So when now you're referencing to that table alias, you have to say the alias dot and then the column name and DEP dot department ID. And now we can execute this query and we will get the results over here. So this employee, the department name is this. For this employee, the department name is this, and so on. Now I've just written a join. But there are three types of joins that we should be aware of. There are 4 or 5 types of joins, but the join that we are most interested in is inner join and left join. And there's also a right join that we'll see an example of. But inner join and left join, these are the 2 joins that you should really understand how they perform. And this is how you should write your queries, not just write a join. By implicitly, it is going to get converted into an inner join. But you have to mention specifically so that anybody who reads your code can understand what exactly is doing. Even when you need to maintain your code and you're going to go back and try to debug your code, you have to write the code in a way that is easily understandable. So inner join, the meaning of inner join is that you will get only those records in the output which have a match in your employee table and the department table. Now to do that, we're just going to, let's take a look at the data again. So select start from department. You can see that there are 5 department IDs. If you do a distinct department ID from employees, let's see how many department IDs we have in the employee table. So we have got only 3 employee IDs, 1, 2, and 3. Whereas in our department tables, the department IDs go all the way till 5. So what I'm going to do is I'm going to say that I want the department name. So I'm going to do an inner join. When I do an inner join, I'm just saying that I want only those records which have a matching record in the department table. So only those records from the department ID table. So only those 3 department IDs, only those 3 department IDs which have a match in the department table. So when you execute this query, you're going to get only those departments which have a match. So HR, sales, and marketing. We did not get the other 2 departments which we had in the department table, which is finance and null. We did not get those values. Now let's say I want all the department IDs and the employees which are working for that department. But even if there are no employees, I want the department ID in my output result set. So in that case, what we are going to use is a left join. So Left join makes sure that whichever is your table on the left end of the join. So this is your left end of the join. So because we want all the records from the department table, this table has to be department. So I'm going to make this table as department, and I'm going to perform a left join. So left join on employees table, and the condition is going to be same because that is the column that we're going to match on. Now what we're saying is I want all the records from the department table and the matching records, the matching values from the employee table. If there is no matching value, still I want that record from the department table to be included in my output. Let's execute this query and see. So here what we have got is we have got all the records for which there is a matching employee ID. So we can go and see towards the end. If we go, we see that for finance, it did not find any employee ID in the employees table. Therefore, when it doesn't find a match, it results in a null value. So for the employee ID column, you can see that there's a null value. And for the department name, null, which was department ID 5, again it could not find any value. Employee ID for whom no assignment was done for the department ID, and therefore a null value was returned. So this is how a left join works. You get all the records from the department ID table and only the matching values from the employee table. So if there are going to be 5 records in the department table, and for each of those 5 records you get each employee ID for those records. So HR, you get these 4 employee IDs for those records, and so on. So this is how a left join works. Now if you make it to a right join, so you can just observe the number of rows over here. There are 12 rows over here. If this would have been an inner join, there are only 10 rows because we do not get rows for those 2 departments which have a null value and the other department which was there. Now if I move it to a right join, the right join does the reverse of the left join, which is it takes all the records from the right table and matches them, only the matching values from the left table. So I'm going to move again my department table to the right part, because for employees all the department IDs are present in the department table, so we will not be able to observe any difference. So now I'm going to get all the department ID values, whether they have an employee ID associated with them or not. So at the bottom, we can see there are 12 rows. And if I scroll down, you will see that there's finance and this department for which there are no employees. So we got 1 record in the output with a value of null. Now there are other aggregate functions which can be performed as well. Let's say we want the sum of salaries of all the employees. We can just say sum of salary as total salary from employees So you get the sum of salary. You can have multiple aggregations. So you can have minimum of salary as well as min salary. And you can have max of salary as well as max salary. And bring it back here. So you can have all these aggregate results in your output. Now, all these have been performed on the complete data for employees. Again, if you want to categorize it, you can use your group by. So you want the values based on your department ID. You can just say a department ID, group by department ID, and select that column over here. And then all these values will be computed for each department ID. Now we can also use subqueries in the where clause, which means to filter the data in slightly more complicated scenarios. So let's say we want to select all the employees which belong to the top 2 departments, and these top 2 departments we are calculating simply by ordering on the department name in the descending order. So let's first do our order by. So we are saying select top 2 department ID, and we are going to select them from the department table, and we are going to order by, which means we are going to sort order by department name in a descending manner. So now we are going to get 2 department IDs over here, which are 2 and 3. Okay, so this is what I want to have as my where criteria. I want to select only those employees which belong to these 2 departments. Now, how do I use this? How do I add this to my select query? How do I write my select query where I have this criteria? And this might change. So if there are new records, new departments which have been created, the department IDs might change based on what values are present at that point of time in my department table. So this has to be in terms of a query. We cannot really hard code anything over here. So how will you write this in terms of your query? What we can use is a subquery. We can make this as a subquery. So what we are going to say is select star from employees where department ID, and since this is a list of values, we are going to say department ID in, and then we are going to use this query, the output from this query. So I'm going to put this within brackets over here, which is going to make it as a subquery, and then I'm going to execute this query. So now I'm going to get only those employees which belong to 2 or 3, which was the output from this particular subquery. Now there's another kind of subquery which is called a correlated subquery, and which makes use of the exists keyword. So now a little more complicated scenario is that I want to select only those department IDs from my department table which have at least one employee associated with them in the employee table. So only those department IDs I want to select. So what I'm going to write is a correlated subquery for this. So what I'm going to say is select star from employees where, because I'm going to filter the output from the employees table, and then you have to use an exists keyword where exists, and we have to give this an alias. So I've given this a table alias as EMP. So what I'm going to say over here is where exists, select employee ID from employees EMP. Sorry, this we have to select from department table, right? So you have to say department. So I gave it the same alias. You can give it the same alias as the table name. So select employee ID from employees EMP where, and you can reference this table here, EMP dot department ID is equal to DPT dot department ID. And if you execute this query, you get only 3 department IDs, because only these 3 department IDs have the employee IDs associated with them. So this is called a correlated subquery, because from within this subquery, we have referenced the table, the outer table, so the main table. So this is called a correlated subquery, and this is used with the exist or not exist keyword. So let's do a not exist and see what happens. So I'm going to execute this query, and you get these 2 departments. So what has basically happened is that we have got those departments which have no employee IDs associated with them. Now there may be a requirement where you want to combine data from 2 different tables. So combine in the sense of you want to add on that data. So I have department ID in my employees table. I also have department ID in my department table. So let's say select department ID from department, and then I have department ID from employees. Now I'm going to do a distinct on the department ID from the employees because I have multiple department IDs because there are multiple employees associated with the same department ID. So I have some department IDs in department table. I have some department IDs in employees table. Let's say I want to combine the department IDs from these two different tables. So what we can do is we can use something called a union all. So if I do a union all and execute this query, I'm going to get some 8 rows, and you can see that the values are repeating. So department ID 1 and department ID 1 comes here again. So there are duplicates in the output. It basically has combined the output from the first query to the output from the second query. But if we think that there might be duplicates and we do not want those duplicates, we have to use a union operator. So you do a union and it is going to make sure that the duplicates are removed from your output result set. Now there are also operations similar to union. So there's something called intersect. So intersect basically means it is going to find out the common department IDs that exist in the first query and the second query. So let's see which IDs are going to come out. Only the 3 department IDs that exist in both the tables. We can also say except. So except is going to give all the department IDs from your first query which do not exist in your second query. So you can use these combination operators as well in your SQL queries. Now, another interesting function, there are many functions that you can use in your SQL queries other than the aggregate functions as well. You can do a trim on the data. So if there is some, let's say, space in your data, you can do a select trim. So this is basically going to be performed on a string column which might have spaces in it. So we are going to say select trim from employees, and this is going to trim out any spaces that you might have. So any spaces that you might have in your data can be trimmed out. Obviously, there are a range of functions that can be used. There are many functions which are available which can be used in this case. Now, if you want to have some conditional output coming out, there's one interesting function that we're going to discuss, and which is the case function. So case is like an if then else. Let's say we want to create a calculated column for all those employees whose salary is greater than 50,000. We are going to say Y. For all those employees whose salary is, let's say, greater than less than 50,000 but greater than 40,000, we are going to say no. And for all the other employees, we are going to give an X. So what we can do over here is, let's bring this down. Let's take the employee ID and salary, and then we're going to write a case statement. So case, you write case. Then you specify your condition. When salary is greater than, let's say, 90,000, then since we are going to give a character, we are going to say Y within quotes. Okay. Then you write your second condition starting with when salary, let's say, between 45,000 and let's say 85,000, then no, else you're going to say X. And when you're done with all your conditions, you have to say and then give it a column name. So this will be, let's say, salary flag. And now we can execute this query. When we execute this query, you will have the correct flag in your calculated column salary flag. So employee ID 1, salary is 35,000, which means it is not greater than 90,000. It is not in this range. So it has been marked with the flag of X. So this is how you can implement an if then else kind of logic in your SQL select statement as well. So these are some of the queries that you should be familiar with. There is obviously a range of functions which you should be aware of. But to start with SQL, you should be basic with these writing these SQL queries and be aware of all these operations that can be performed. In part 2 of this series, we are going to solve some questions from lead code which are of the easy level. So there will be lots of practice exercises, and once you're comfortable with these concepts, you can perform these practice exercises, and this will help you in writing the SQL queries. All the database that we have used in this exercise and all the SQL commands that we have written in this exercise will be provided in the description link below. So be sure to click on that. And if you liked the video and found it useful, please do subscribe to our YouTube channel, and do not forget to like, comment, and share this video. Also, if you want a video on any particular topic, put it down in the comments below, and we'll see you in the next practice exercises session for the SQL Beginners course. Thanks a lot for watching. Goodbye.